All right. All right, my great student, Master's Vessel Classical student, I welcome you to another series of chemistry. The last time we started with metals and its compound, and we are still on that topic, metal and its compound. But today, we'll be looking at occurrence. We're looking at occurrence of metals. We'll be looking at extraction of metal. We'll be looking at principles of extraction of metal. Perhaps we may still look at alloys. We may still look at alloys. Let's look at the occurrence of metals. Occurrence of metal. These are areas and places where a metal can be found. And we need to define this ore and gangue. Ore is a substance containing the preferred metal. Ore mineral is a substance containing the preferred metal. Ore is a substance containing the preferred metal. In its natural state. I say that ore is a substance containing the preferred metal in its natural state. Gangue. Gangue is the impurities contained in an ore. Gangue is impurities contained in an ore. But let's go back to what we call occurrence of metals. We will use Nigeria as an example. We'll use Nigeria as an example. We have ore mineral as such called hematite. Hematite is iron 3 oxide, Fe2O3. And this hematite is also called iron ore. Iron ore. It is from this hematite, Fe2O3, that iron is extracted. In Nigeria, hematite can be found in Kogi State. Kogi State. Specifically in Itape. Itape in Kogi State. Then we have another ore mineral called Though this one is not actually, you have gold. Gold in actual sense contain gangs, but the gang mineral in gold is not a compound. It doesn't react with gold. Therefore, gold can be found in several places in Nigeria, in Niger State, in Osun, in Kebbi, in Kaduna, in Kogi, and odd Zamfara states. If you look at what is happening in Nigeria, some of these bandits you talk about, what is causing it is people who are exploring for gold or any other minerals. They have opposition, and most of the time they will fight, especially gold in Zamfara and so on. If you look at where they are exploring some of these minerals such as gold, you will see that there is banditry there because of superiority conflict. Therefore, gold can be found in Osun State. It can be found in Zamfara State. It can be found in Kebbi State. Then we'll look at another mineral, barium ore, which is called barite. Barium ore, simply called barite. Barium ore is found in Nasarawa, it's found in Nasarawa, it's found in Taraba and Benue State. We look at another mineral called Cassiterite. Look at another mineral called Cassiterite. Cassiterite is tin 2 oxide, SnO2. Tin 2 oxide. Tin 2 oxide is found in Plateau State. Tin 2 oxide is found in Plateau State. It's also found in Nasarawa State, Kano, and so on. Let us look at, we've talked about occurrence. We have seen where some of these metals, the ore minerals, the locations where they can be found. Let's now look at extraction of metal. How do we extract the metal? Because when you look at most of these ore minerals, you see that they exist as compound, except gold. The other mineral exists as compound. Therefore, how do we now produce the metal? That brings us to extraction of metal. For us to discuss about extraction of metal, we must have a knowledge of the activity series or electrochemical series. I've mentioned this before. I said that activity series is the arrangement of elements in decreasing order of activity. You have potassium, which has the highest reactivity, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper. The people will add hydrogen here. Hydrogen is not a metal, but some people will add hydrogen here. I will explain to you why hydrogen is there. You know that hydrogen is a non-metal, but is grouped in group 1 because it has 1 electron in the outermost shell. Based on that, hydrogen occurs in the activity series and is between tin and lead. No, it's between copper and lead. If you have this activity series, it will help you to know the principle you are going to use for extraction. Look at from potassium to aluminum. The extraction principle is by electrolytic reduction. And the reason why it is by electrolytic reduction is because these metals, from potassium to aluminum, they exist as a ionic compound. Their ores are ionic compound. And because they are ionic compound, they have strong electrostatic attraction. They are held together strongly. Because they are held together strongly, you cannot use ordinary chemical reduction to separate them. You now use electrolytic reduction. Therefore, you can see that the minerals of calcium to aluminum can only be extracted by electrolytic reduction. Then from zinc to lead. From zinc to lead or even to tin is done by chemical reduction. Then you know you have hydrogen here. Then from copper down is done by thermal reduction. Maybe there will be need for us to know, say, what is reduction. Reduction is either addition of hydrogen or removal of oxygen or decrease in oxidation number or addition of electrons. Remember, I've given you so many definitions. I've given you so many definitions of reduction. I've given you so many definitions of reduction. If you remember what we did before, if there is a reaction where you have addition of hydrogen, you call it reduction. If there is a reaction in which you remove oxygen from a substance, you call it reduction. And if you look at here, for instance, iron, Fe2O3. If you remove oxygen from iron 3 oxide, you produce iron. That is reduction. That is reduction. If you have maybe zinc triosocarbonate 4, if you convert this thing to zinc oxide. If you remove oxygen and you produce zinc, that is reduction. But the most important thing is that you should know that from potassium to aluminum, it is electrolytic reduction. From zinc to tin, it is chemical reduction. Then you have copper, and the other ones down is called thermal reduction. Thermal reduction is when you heat up the ore, you produce the metal. For that is the principle of extraction of metal. That is the principle of extraction of metal. We have seen that those very reactive elements are extracted by electrolytic reduction. The ones that are not very reactive, from zinc, you produce by chemical reduction. The ones that are very less reactive, you produce by thermal reduction. This chemical reduction is usually done by coke or carbon 2 oxide. For if you use carbon 2 oxide, if you remove oxygen, it will form carbon 4 oxide. If you use coke, which is carbon, you will form carbon. It will remove oxygen from the metal, the ore, and you will now form the metal and CO2. For that is principle of extraction of metal. For let us look at another thing, alloys. Alloys. We need to look at alloys before we can now go to discuss the metal one by one, starting from sodium. But let's look at alloys. I know that most of us know what an alloy is, because in the junior secondary, you discuss it. In the senior secondary, when you are doing element, compound, and mixture, you equally mention about alloys. Therefore, alloys are mixture of two or more metals and or non-metal to form a substance with better properties. To form a substance with better properties. Let me give you an instance. You have iron. Ordinary iron corrode. But if you look at stainless steel made from iron, carbon, and other metals, you see that it doesn't corrode. Therefore, for you to make iron not to corrode, you use it to form an alloy which cannot corrode. For we've said, and examples of alloys are things like bronze. You have stainless steel. You have duralumin, and so on. We will need to know some of the components. Therefore, we'll look at reason for making alloys. Reason for making alloys. Why do we make alloys? I've defined an alloy for you. Why do we make alloys? Why do we make alloys? Without discussing it, I want to ask you, why do we make alloys? Because we have defined alloys. Why do we make alloys, Obi? Yes? You say that we make alloys to have metal or substances that give better properties. That's one of them. That's one of them. But let us list it maybe in three. One of the reasons, one, alloys are harder than the parent metal. Alloys are harder than parent metal with a better mechanical strength. Therefore, we make alloys to obtain metals with that are harder and with better mechanical strength. 2, alloys are resistant to corrosion. Remember, we say, why do we make alloys? We want to obtain metals that are resistant to corrosion. For instance, I've mentioned to you stainless steel. Stainless steel, which is made up of iron, chromium, carbon, and nickel. For when you have stainless steel, you see that it's resistant corrosion. Then you have steel. Steel, which is equally resistant to corrosion to some extent, is made up of iron and carbon. Therefore, I said one of the reasons why we make alloys is to obtain metals that are resistant to corrosion. Then the third one, alloys have a better physical appearance. We see some of the alloys we use in making coin. You see how the coin have better appearance. You look at even the stainless steel, how it looks better than if it's ordinary iron. Therefore, we alloy to have metal with better appearance. Then the fourth one is alloys. Is used to increase the melting point in some metals or decrease the melting point of metal, depending on what you want. If you want the melting point to be low, you add another metal that will reduce the melting point, and so on and so forth. For these are some of the importance of why we make alloys. For let me round up with giving you some alloys and their components. I've already said steel. Steel is made up of iron and carbon. And I mentioned stainless steel is made up of iron, carbon, chromium, and nickel. Then we have bronze. Bronze is made up of copper and tin. Brass is made up of copper and zinc. Duralumin is made up of aluminum, copper, manganese, and magnesium. And some of the uses, you know that steel is used in building structures like bridges. Therefore, it will increase the mechanical strength. Stainless steel, you use it in making your cutleries and your kitchen utensils because it resists corrosion. Bronze, you can see that it's used in making coins and so on. Brass, use it in making plates. What they give you when you do well in sporting activities and so on. Aluminum is used in making and producing aeroplane and so on. Therefore, my students will stop here. Today we have seen the occurrence of metals. Some of the metals where they occur in Nigeria, we say that iron ore is found in Kogi State, in Etape. We say that gold is found in Osun. We say that it's also found in Zamfara. I've told you too that some of the banditry you see in the north is where they are struggling to, steal some of our mineral resources. Some of the people coming from abroad goes there to go and mine for gold. Most of the time they don't pay what they are supposed to pay to government. Then I said that barite is also an ore mineral. I said that cassiterite is found in Plateau, and cassiterite is the tin ore. Then we talked about definition of ore. I said that ore is a mineral, is a substance containing the iron of importance to us with the impurities. Then I said that gangue is the impurities found in an ore. Then we looked at extraction of metal. I said that the most reactive metals are extracted by electrolysis, and the ones that are not quite very reactive are extracted by chemical reduction, and the unreactive ones is produced by thermal reduction. For we now went to alloys, and I said that alloys is a mixture of two or more metals with and or non-metal that gives you a desirable quality. Then I mentioned some of the reasons why we make alloys. I said that we want to obtain metal with harder and better mechanical strength. The second one, I said alloys is used to improve the physical appearance of a metal. Then thirdly, I said that alloys are made to obtain metals that are corrosion resistant. Then I mentioned some of the alloys and their composition. For we are going to stop here, and in your assignment, state one, state the method of extraction of the metals in the following ore mineral, and why. Why is it? Why do you use the method? 1. Hematite. Fe2O3. You have Cassiterite. SnO2. You have limestone. CaCO3. Then you have bauxite. Bauxite is Al2O3. These underlying elements are metals. How do we extract them and why? You tell me the method you use in the extraction and the reason why you propose that method. And thank you for listening. Stay safe and remain blessed. Thank you.